Hi, everyone. Welcome to the January Layer 7 office hours. I'm Pamela Deesa, Marketing Manager for Layer 7. Today, we have with us Christian Oberly, and he's going to be sharing the topic of using ArgoCD to automate Layer 7 deployment on Kubernetes. So just to let you all know, we're going to ask you to save questions until the end this time. So at the end of the presentation, I will unmute you guys so that you can come off and ask your questions directly of Christian. However, if you do think of questions during the presentation, feel free to type them in the panel. You can do that as well. So that's it for my intro. I hope you enjoy, I'm sure you will, the presentation. And I'm going to turn it over to Christian now. Thank you, Christian.
Hi, thanks Pamela. Hi, everybody. Thanks a lot. Today, and I'm going in this office hours, going to, the first office hours for 2026. I'm going to talk about Argo continuous deployment solution, so ArgoCD, and how it can be used to automate the deployment of the Layer 7 API gateway into Kubernetes. As Kubernetes is gaining more and more adoption, so does ArgoCD tool. And this is why we thought it would be useful to see, how in practice, how this can be leveraged to deploy the Layer 7 gateway or API security solution. So I will first start with a quick intro of what Argo exactly is and how it works and what are the benefits of ArgoCD. Then I basically constructed 3 interesting use cases to talk about the deployment of the Layer 7 security gateway. And then we'll go into a demo mode where I'll show you how those 3 use cases in practice and in action. So to start with, how the ArgoCD works, and it's labeled as a declarative GitOps continuous deployment for Kubernetes. We all know Jenkins and other CI/CD tools. And it differs from Jenkins, for example, in the case that it's basically pulling the configuration from a Git repository and then applies this configuration to update or create a Kubernetes cluster. It's in continuously monitoring the Git repo and balancing that with the actual Kubernetes deployment to see if there are differences. And if there are differences, then it updates the Kubernetes cluster. So it basically puts a clear separation between continuous integration and continuous deployment, and enables a smooth and a more secure deployment of application. Typically with other CI/CD platforms which are more in a push mode versus the pull mode that ArgoCD enforces, developers basically make changes to the application, and then they basically have a kubectl apply command, and this gets pushed to the platform. And then when it's pushed, there is little capability of seeing exactly what the state is, and there is a bit of confusion between the deployments and what the status of the application here is. In this pull model, the Git repo is basically the barrier between the developer world and the operational world, and everything. Developers basically push the configuration, make commits to a Git repo, and then ArgoCD pulls that from the Git repo to update the Kubernetes platform. So there is a clear line of demarcation between continuous integration and continuous deployment, and it's basically very well aligned with the GitOps principles, as you can see. So some of the features and benefits of this solution, which are pretty obvious, is, as I said, it's a pull deployment model versus other tools like Jenkins, which are more a push deployment model with a clear separation between CI, continuous integration, and continuous deployment. And also that basically brings a major, I would say, benefit, in the sense that when you have developers pushing their configuration to the platform, well, they have to know the security credentials to be able to put that configuration to the platform. In this case, the credentials would be shared by many developers, and spread out in the wild. While with ArgoCD, Argo is basically pulling the configuration. Only ArgoCD knows the credentials, and it's quite more secure than the other model. That doesn't mean that Jenkins or other CI/CD tools are not valid. They are very valid for continuous integration, definitely. ArgoCD is Kubernetes native. It's basically deployed as a Kubernetes application on Kubernetes, so it leverages etcd for storage and Kubernetes controllers for monitoring. As I've said, basically ArgoCD does observe the Git repository, compares that with the actual platform configuration, and if there is a difference, it will update the platform. So it leverages the Kubernetes controllers, and it's built to support Helm charts, customize, and JSON-net for deployment. Git is the source of truth, and this is why we say it's very GitOps aligned with the GitOps principles. Git is the source of truth, where your application, your configuration is stored, and basically version controlled as well. So if you make changes to your application, you commit to Git, and then you have the ability to trace what your commits are. And ArgoCD also leverages those capabilities for version controlling the different deployments that you have made to your application on Kubernetes. It has deployment automation, so changes on Git are automatically reflected on Kubernetes. So there is a synchronization mechanism between that ArgoCD does handle. So it observes your Git repository and synchronizes with your target's platform on Kubernetes. ArgoCD does monitor your Git repository, and you can either do a manual synchronization, as we'll do in the demo, or you can automate that synchronization, and then there is a bit of elapsed time, like 3 minutes, and every 3 minutes ArgoCD monitors, checks your Git repo. If there is a change, it will apply it to your Kubernetes platform. Likewise, if somebody goes directly on the platform where your application is deployed and does make changes, ArgoCD will spot those changes and reapply the configuration that is stored on Git. So there is, it's quite, of course, there are configurations to, keep those changes, but in principle, you should not allow somebody to change your configuration on the working application. So ArgoCD will reapply the configuration that is on Git. As I said, a great benefit of ArgoCD is the ability to provide visibility of your application once it's deployed. Contrary to developers, applying kubectl apply commands to update your application, and then you don't exactly know what has been applied by who and when. ArgoCD has a UI, and you have a clear visibility of your application once it's deployed, and we'll see that through the UI. You can have also an easy rollback, as everything is tracked and monitored, and it leverages the GitOps principles where everything is tracked. You can roll back to previous version, and you have version control with audit trails in ArgoCD. And last but not least, if your application does crash on the production platform or on the platform where it's deployed, you basically use Argo to recreate your application or your cluster from scratch, and it basically pulls the configuration that was stored on Git and redeploys the application as it was. So even contrary to the other push model, it's Argo who basically pulls the configuration. So if somebody in a push model does make updates, well, you don't know exactly what the latest configuration was. This doesn't happen with ArgoCD because it's being pulled from your Git environment. So these are a couple of key benefits, and this is why ArgoCD, which is designed by people primarily not as CD on top of a CI tool, but basically built in for Kubernetes by people operating platform, makes it very attractive to deploy applications on Kubernetes. And this is why we felt it would be good to show you how this can be used to deploy Layer 7 security gateway on Kubernetes as well. So moving on, regarding the Argo settings, the deployment of Argo is pretty easy. You create a namespace called ArgoCD, and then you apply this configuration file, and it creates a couple of pods, which I will show you. And with that, you have the ability to create application either through a UI. So it's pretty much UI driven, so you can create applications, or you have a rich command line to create your applications and monitor your application and the configuration of your environment. We'll use both in the demonstration. So I will basically use the CLI to create the applications, and I will show you how those applications are created on the UI. But you have, it's good to know that you have both. And as I said, ArgoCD provides the ability to view the deployment of your application, and it's, as you see here, pretty useful and pretty interesting. In terms of the demo setup, so I have everything running on my local Mac workstation. I have a Kind cluster where I deployed ArgoCD in the ArgoCD namespace, and I will deploy my Layer 7 gateway into the Layer 7 namespace. I have 3 applications corresponding to 3 cases, which I will explore just after this slide. And ArgoCD basically will pull the configuration from a public repository where we have our Helm chart stored for the gateways, and also a private repository, which is where I have my configuration stored, my Helm value stored for case 2 and case 3. The connection between ArgoCD, I basically created an access token on my Git repository, so my personal Git repository, and basically I configured Argo, as you can see here, to use that token to connect to my Git repository and fetch the configuration that is needed to deploy the second and third application. So the 3 use cases I'm going to show you. The first use case is a very, I would say, simple gateway deployment. And in this very simple use case, the values for my gateway configuration that I would define in the Helm charts are basically defined in the ArgoCD application definition file. So in ArgoCD, you can create, as I said, the application through the UI, or you can basically run a command, which I will show you. That command will refer an application definition file, and you can configure your specific Helm values in this file. Now, these my application, my Layer 7 application, does use 2 secrets. One is a secret for the policy manager, and another one is a secret for the license. And these ones are basically defined using customize outside the Argo application definition. The second use case I'm going to show you is, I would say, an extension of this first use case, whereby you don't want to mix basically your application definition and your application configuration. So the definition of the application is basically a reference to my Helm chart, but the values to configure my application are defined in a values file that is referenced in my private Git repository. I'm also using customize to basically create my secret and my license. And in this case, customize is basically part of the application definition, and ArgoCD will take care of that. So both the creation of my secrets and license that are needed for my application, as well as the deployment of my Layer 7 gateway with the right configuration defined in the values of the YAML file. The third use case, I would say, is the most advanced use case and is the most interesting one, because it combines the usage of ArgoCD together with the Layer 7 operator. And we have an operator that basically manages gateway and repository custom resource definition file. So what we do here is we use the Layer 7 custom resource definition file, and customized is used for the configuration that is also included in Argo application definition. I will show you how that works to make a quite powerful deployment of the Layer 7 gateway, as well as updating the configuration of the Layer 7 gateway, because as we have already explained in previous office hours, the Layer 7 operators also does manage repositories and configuration to dynamically upgrade the configuration of the gateway. So coming back to the first use case, this is my manifest file for the first application that I'm going to deploy. And as you can see here, ArgoCD basically creates a CID for defining an application. So this is my application. It's a gateway. I'm referring here my Helm chart, and in this Helm chart, this version 3.0.41 corresponds to a gateway 11.2 version. In this application file, I'm also defining my Helm configuration, so some custom parameters, like I will deploy a database. So here I have a screenshot with database false, but you will see in my scenario, the database will be created. And here you will see what I mentioned before, that I'm leveraging or I'm referring the two secrets, one for the license and one for the credentials to access the policy manager. These secrets are being defined using customized outside the ArgoCD platform. In the second use case, you see that you have more resources or sources to basically create the application. So I'm still creating and deploying my application into the Layer7 namespace. And this is a reference to where my Kubernetes cluster is running. So this is my local kind cluster. And ArgoCD is a tool that is built to deploy on a number of clusters. So you can have one instance of ArgoCD to deploy your application in different clusters, and you can refer different or multiple servers if you want to deploy the application to different clusters. As part of the source for defining my application, I have, as I had before for the first case, I have the definition of my repository where I have the Helm chart for my gateway. And I also here have the location of my private repository where I have my Helm values or the value file that defines my configuration or of the Helm charts. This is a reference actually, and here you see that these references that are defined here are basically being used when I point to my Helm chart. So what ArgoCD does, it pulls my values file and basically takes those values and updates or creates the final chart for deploying the application. And the last source is basically my customize file where I have my configuration for the license and the credentials, so the SSG secret and SSG license. Also here, contrary to the first use case, I define a sync policy where I basically say, it's automated, synced automatically, and I have a prune status. So ArgoCD provides a lot of capability for defining how you do the synchronization. Pruning is basically if a reference is available on Git, but available on your target platform, but no longer available on Git, it will then remove it from the platform where the application is defined. So I'm not going to go into the details too much of all the details of Argo because it's pretty rich, but you can have fine ways of tuning how the deployment and the synchronization is being made. The first case, you see here that the application definition file, the manifest file for the application is pretty simple. This is because we're leveraging the Layer7 operator in the backend. In this case, I'm still referring my Helm chart. And basically, as I said, ArgoCD is using customize. So here, I'm basically using a gateway custom resource definition. So that will be used by the Layer7 operator to create the gateway. So it's our own custom resource definition. And basically, we also have here a pointer to the customized file. So the customized file will basically define the resource. So the custom resource, which is the gateway, and the settings. So it will define the local boot repository, the secrets, and the way it works is basically when you deploy, so we first deploy the operator, which will control and monitor the gateway custom resource and the gateway repository. And when we deploy the application into the layer 7 namespace, basically Kustomize will build a resource that includes the repository and gateway custom resource definitions. And then these resources created by Argo are picked up by the layer 7 operator, and the gateway is created with the configuration obtained from the boot repository. So it's a two-step scenario, but it's pretty efficient and does leverage our layer 7 operator and the corresponding gateway and repository custom resource definition that we have. So with that overview, let me switch into demo mode and show you the different settings. So first thing first, this is the ArgoCD documentation, where you see here how to install ArgoCD, and it's pretty easy to install it. Once you installed it, I have here a make file where I have all my comments that I will be using to make the demo as smooth as possible. But what you see here, when I want to see what my ArgoCD deployment is in the ArgoCD namespace, I see here my pods running, and I see here the different services exposed by ArgoCD, especially the ArgoCD repository server, where I have the UI. So if I go here, you see here, this is my ArgoCD UI. I have no application deployed yet. And in terms of settings, I have pre-configured, and this is where you can configure your repository, but I have pre-configured my Git repository for the case 2 and 3. So now let me deploy my first application. So I'm going to first create my secrets and my license. So I basically run this make set one command, which is basically creating my settings. So here is my folder where I have my customization file. This customization file defines my secret and my license, and I'm referring here my license and my secrets. And that basically applies this customization file to my layer 7 namespace on my local kind cluster. I also added a Helm search repo command, so that you see here in my repository, I have the chart version 3041 that corresponds to gateway 11.2 as I mentioned. So the second step here is basically I'm going to create my ArgoCD command. So if I type here ArgoCD, just ArgoCD, you'll see here all the command lines that Argo has. So a lot of capabilities, but I'm just basically going to now apply my manifest file. And in this manifest file, as we have seen before, just a refresher, I'm referring my charts, the version of my chart that corresponds to gateway 11.2. I'm creating a database, and I'm referring to my two secrets for the license and the secrets to basically connect to the policy manager. So let me run make app1. And as soon as I run this file, basically the application is created. So if I see here that my application is created, but it's not yet deployed or synchronized. Okay, so I'm going to write make sync1, and that basically does launch the synchronization of my application. So make sync1 is basically the ArgoCD application sync, and I sync my SSG1 application, which was created previously. So if I now go back and click here, you see that my MySQL database is being created, and you will see how the application is progressively being created. So you have everything that unfolds, I would say, here. And when I look at my application details, I have the cluster, so it's my local cluster. I have a lot of information, and I can also see here the parameters that I define into my application configuration. So here in my manifest file, you see that I have some Helm parameters that I defined in my application configuration. these Helm parameters are visible here, and you see the secrets and the license that were picked up. And if you go down, you see all the other parameters that are basically being picked up from the gateway Helm chart. So as the application deploys, you see here there are some movements in the background. I'm going to show you, this is the gateway Helm charts, and here you have all the values that you could configure. And this is basically being picked up automatically by ArgoCD for the deployment of the application. So let me just close that. And you see now that my application is deployed and synchronized. You can see the different pods, the services, the MySQL database, and here you can also have a view of the logs. You can do some search on the logs to verify that everything has been well deployed. And ArgoCD provides also the ability to have a view of the different pods running. So it's pretty neat and pretty useful for the deployment. One thing that is that I'm going to show you, I'm going to do a port forward. So if I go here and I run this command here, sorry, it's the first one. Okay, so now I can connect to my policy manager. I proceed to my local host. I log in, and you can see here through our new policy web-based policy manager, you can see here my cluster-wide property, and especially the value ArgoCD, which I defined in my gateway configuration, which was here xname, and the value ArgoCD, which was picked up. So that's for the first use cases, and it shows you how easy it is to deploy an application. Now, all by this application is pretty, pretty simple. And as I said, it does not separate the application definition file, so the manifest that defines the application, from the values that you have defined for the configuration of your application. So let me now switch to the second use case. And for that, I'm going to delete my application. So I'm going to make delete 1. And that basically deletes my ArgoCD application. And you see here that the application will be automatically deleted by ArgoCD. So it takes a few seconds. And now my application is deleted. So switching to the second use case, just as a quick reminder, the second use case is basically I have my application chart, which is on the same location, but my configuration of the application is in a private Git repository. So I basically connected my my private repository with ArgoCD, or I gave ArgoCD access to my private CD through a token, and my private repository is here. So this is the here. Yeah, this is my private repository where I have my settings that are published. Okay, for that purpose, I'm using GitHub Desktop. Okay, so here I basically have a customization file, and that customization file defines, as I said before, my secret and my license. And I also have here my values file, where I basically have my cluster properties and all other configurations. So in this case, I'm not using a database, and I'm referring to my secret and my license. So here you see a clear separation between the manifest file, where I define my application, and I'm having pointers to my customized file as well as to my values file, and the values that configures the application are defined separately into this values.yaml file. So it's more well defined, I would say, than with the first use case, where everything is pretty much mixed and matched. The application definition for ArgoCD contains as well the values that configure or are used by Helm. So let me deploy now my second application. So I'm picking up my second manifest file. I can see here that my application is being deployed. So by running ArgoCD application list, I see that my application name is ArgoCD SSG2. It's deployed on my local target, and it's syncing. Okay, so I'm just going to make sync to force the make sync 2. Sorry, to force the syncing, and you see here that syncing is in progress. And if I go to my application here, you see that the syncing is progressing. So here again, on the difference from the previous use case, you see that my license here, my secret, are defined by ArgoCD. This is why when I discuss the use cases, I basically said in these use cases, the definition of the secret license were external to the Argo application. In this case, it's included into the Argo application definition. And as I said, this is possible because Argo does support Helm, Customize, and JSON-net for deployment. So coming back to the configuration, you see here that my application is currently being deployed. And if I click here, it's being synced. So I can now, the syncing is done. I can do a port forward to my application. And if I connect here to the policy manager, I reload. You see here that I have many more cluster properties. I have my ArgoCD cluster property, but all the cluster properties that were defined in these values.yaml file are now, appearing or are part of my my gateway configuration, which I see here. So that's a pretty fast deployment, and this is, I would say, a typical use case where you have if you want to deploy the Layer7 API security gateway without using the operator, this is a very typical use case whereby you basically separate the application definition file for ArgoCD from your values that configures your application. So let me now switch to the third use case. So I'm going to clean this environment. Okay, and this is now the third use case. So let me show you. Oops. As I said, for this first case, I'm leveraging the Layer7 operator. So everything related to the operator is defined into this GitHub page. So it explains how to deploy the operator, and basically the operator does manage custom resources like the gateway custom resource or the repository custom resource. The deployment of the operator is pretty simple, and I deployed it upfront to save some time, but you basically apply these simple commands for the deployment of the operator. Now let me create the third application. So if I do here make list, you see that I have no application created. If I go here to application, I have no application created. I have my repository that basically is still defined in ArgoCD. And now let me create my third application, make app 3. So the application now is created, and you see here the application is created and everything is already very fast. It's being created, the secrets are created, the local boot repository is created, and basically the application now is being deployed by the operator. So as I said, let me just rewind a bit. Here we leverage the operator. So basically the operator does manage a custom resource definition, and this is the custom resource definition that defines my gateway. In this custom resource definition, I'm basically referencing a local boot repository. So this is the repository that will boot against when spinning up the gateway. This repository is also created by the operator, and all the configuration are defined with this customization file. So you have the two custom resource definition, the local repository and the gateway, and you have the secrets that are needed for to basically create the gateway. So the secrets and the license file. So everything is now managed by basically a combination of customization to create those custom resource definition, as well as the layer 7 operator that will observe the layer 7 namespace and basically create the gateway as per the configuration file. So the application deployment is actually pretty easy, because the only thing it does, it pushes the customization file to the Kubernetes platform. ArgoCD creates the customization based on this customization file, and then you have the operator that picks up this customization to create the gateway as configured. So here I have my gateway that is up and running, and what I can show you here, I'm going to, as for the previous application, I'm going to do a port forward, and I can now connect to my gateway. So let me reload, because of course, as we have recreated the application, the mapping is not the same. So this is why the network mapping is not the same. So this is why you have this message. So let me log in. Oops. And now you see here that the gateway was created. I have in my boot repository, I had a test service that was defined. This is my test service. It is defined as policy as code. For those that have already had a look at policy as code, and you see here that my service is basically created and can be modified and configured. I also see, you see here my cluster-wide properties and my value ArgoCD. So one thing I mentioned, and let me show you, that ArgoCD is pretty good in maintaining, observing the desired state and mapping this, and spotting changes on the desired state versus the actual state. So let us just show you how that works. Here I'm in my boot configuration. Let me change this value X name, okay, and change it to office hours. Okay, so I save it, okay, and now I'm going to push this to my Git repository. So X name is changed to office hours. I commit this and I push this to my repo. And you see here, ArgoCD, I'm going to sync it. So it's pretty fast. So let me put this here, make sync. As I said, you have manual synchronization capability or automated synchronization. And you see it was basically synced. And because of the operator, the value was picked up automatically. I have dynamic upgrades of the gateway. So in theory, I should basically, if I go back to the policy manager, and let me log out and log in again, I should see a different, if the syncing, and why I basically have updated my value. And this was super fast. I mean, basically, it's a two-step process. We push the configuration with Git to the repository. This is being picked by ArgoCD, and then Argo, the layer 7 operator does upgrade because it does monitor the custom resource, the repository custom resource. It basically dynamically upgrades using Grafman the gateway. The interesting thing as well that you can see with ArgoCD is I have here my initial deployment that was done 6 minutes ago, and that was the initial deployment. And here you see that I changed my value to office hours. So that's the upgrade that was done. And you see how ArgoCD provides you with a comprehensive view of the upgrades that have been performed to your solution. So that's pretty powerful. And basically, it illustrates what I mentioned in terms of complete visibility of your application once it's deployed, because it's really picking up what has been changed and updated on the Git repository. So everybody, in a different push model, typically, people would apply. You would no longer exactly know what's going on. You would lose visibility on your deployment. And with ArgoCD, you basically have a pretty neat, observability in terms of deployment and continuous deployment of your solution. So that basically concludes, this presentation and demonstration, Pamela. And I'm now open for questions if there are any. Thanks a lot.
Okay, great. Thank you. Thank you so much, Christian. Let me unmute everyone. Okay. So now you guys are able to come off mute if you have comments or questions that you would like to ask. I do see one comment here. It looks like a comment. Christian, it's not really a question, from David Vanell, I think. It just basically is saying case 2 will work well in large organizations because it is often a different platform team controlling ArgoCD, and it's better to keep the gateway config in a repo that you can control. And David, if you want to come off mute and add anything, feel free.
Yeah, hi, this is just the way it turned out for us. You have kind of like a platform team that you deal with, and they typically will manage ArgoCD, OpenShift, and whatever else is in there. And in most cases, you want to be in control of the layer 7 configuration. And if you put it into the ArgoCD config, you're not going to be able to do that. So yeah, the use case 2 in an enterprise scenario is probably going to work better for you. That was my initial observation.
Yeah, definitely. I mean, I basically concur to what you say, that it introduces a real barrier between everything that is prior to, or that is development, basically stops at the Git repo where you have your configuration, and then another team can that does manage the deployments is picking the artifacts from this repository, and has the right to connect to this repository through the proper configuration and access tokens to pick this this application configuration. Yeah, definitely.
Yeah, and the second thing was around policies as well. So what we ended up doing, because config maps to those policies are kind of quite restricted, that doesn't work for larger policies. So we had effectively 2 repos, one for the gateway configuration and a second one for the policy configuration. So some of my colleagues have developed a CI/CD process that works so that essentially you fire up Policy Manager, make some changes, you run Grafman, that feeds it back into the policy repo, and at the same time, a little tag gets tweaked in the gateway Helm chart, which causes ArgoCD to auto-deploy and doing a rolling update of the gateways to deploy those policies, and that works really nicely. So yeah, there's 2 sides to it. There's
hello, Christian. Sorry. Okay, sorry.
I was listening, and I don't think I have much to add. No, I mean, I'm super happy that you you're sharing your experience, because it shows that you are already using ArgoCD pretty effectively, I would say. So yes, as you mentioned, there is indeed a limit, a size limit, for storing policies into config maps, which is 1 megabyte. You can have init containers, so you have lots of different capabilities. I'm not going to go into the capabilities that we offer to basically preload, policies and configuration. But I do concur with you that, with Grafman, you have configuration as code, so you can say, okay, I have, this is what I want to see in my gateway, or how I want my gateway to be configured when I bootstrap it. And this is something that is in my boot repository, and I have everything else that's basically here in my environment. The full illustration, I had some cluster properties, but I also had internal IDPs, internal users, etc., JDBC connections. And if I would connect to the gateway with Policy Manager 1, I would see these. We're upgrading the Policy Manager in a few weeks, PM2 in a few weeks, that will have more capability to see all those artifacts. So definitely you have having configuration as code makes a lot of sense, and we do support all of these. I haven't shown here something pretty neat, which is I really like a lot. Is with PM1 you can import gateway bundles, and definitely I could load here additional policies and bundles. Here I have audit hello, which I could load, and it will automatically create everything that is needed. So there are lots of ways to fine-tune your deployment after the fact, once it's deployed. Yeah, but definitely good practice to separate the configuration, cluster-wide properties, JDBC connections, etc., from the effectual the policies that you want to have when your gateway is deployed. Yeah. I don't know if Ben or Aaron or Greg are connected, but feel free to comment as well if you have other things that you want to add around the configuration, the policy manager. Just feel free to add on.
I also see a hand raised. Vince Baker, I don't know if you mean to raise your hand.
Hello. Yes, I do. You know me. You know me very well. Yeah, Christian. So, do you see any immediate issues with using ArgoCD for when you use this for developer portal, basically, because you've got the operator that is coming out for the developer portal? Do you think that should be okay to do the same sort of thing? I know it's not quite so, articulate, but
so
what do you think?
So what I would say here is I haven't. There is no reason why ArgoCD basically takes. If I look at the second use case, the second use case doesn't use operators at all. So it just uses hand charts and values fine, as does the first, which is pretty basic. But I haven't tested personally the deployment of the portal using ArgoCD. It's on my to-do list. I see no reason why it should not work, but evil is in the details. And I think once the operator is available for the portal, a similar principle will apply. So this is something we definitely are going to actively look into it, because as I said, the more and more customers are embracing Kubernetes platforms and container deployments. And ArgoCD is really, there are other tools there, but I've personally found it pretty neat to use. And I had some customers using it. I didn't know that PTSB, David, was using it, but good to hear that you're using it. And I guess it's basically, it was designed, as mentioned, as a customer Kubernetes native platform. So it has a natural fit with Kubernetes, and yeah, we'll definitely look into the possibility of deploying the portal as well with ArgoCD.
Yeah, Vince, I see. Are you talking about portal APIs?
I was just going to say we're running the portal using ArgoCD deployment in multiple environments at the moment. It works just fine. The only thing is that some of the pods are slightly larger than standard size, but yeah, it does run.
Yeah, good to know. And are you using that
Okay,
like
cool.
published APIs to control those as well?
Sorry, second.
Are you using that to like control the deployment of like portal published APIs from the portal, or is it more about just setting up the portal itself?
No, it's just about running the portal itself.
Okay.
And yeah, the portals at the moment, yes, some of them are running OpenShift, but the gateways they're controlling are not in OpenShift. They're outside of that. They are virtual machines, VMware stuff.
Okay, thanks.
My question.
Put my hand down again.
Question.
Hang on. There you go.
That's right. Yeah, a question. Is there any plan to support ephemeral gateways and portal integration?
Yes, that technically with the operator at least is supported now.
Okay, because we're looking into a migration of the other workloads into OpenShift, and the portal integration thing is kind of a little bit of a speed bump at the moment.
Yeah, reach out to me if you want to dig into that a little deeper, but yeah, especially with the operator integration with portal, the ephemeral gateway should work now. There might be a few things we need to work through, as Christian said, the devil's in the details, but technically it should work.
Okay, that sounds promising. Thanks.
Okay, I'm not seeing any other hands raised or questions, but again, you guys can come off mute and ask. I do think we have had one. Greg Brzezina, do you want to ask your question or give a comment? Okay, I think basically he's just saying thank you, Christian, for your presentation and that you did a good job, which you did. So thank you.
Well, thanks a lot. Thanks for your attention. And as said, don't hesitate to reach out, look at the community pages, interact with us. There are many channels. So we're here to listen to your feedback. And David, thanks a lot. Great to hear that you deployed a portal with ArgoCD and it's working fine. So any feedback that you want to share on the usage of ArgoCD for deployment, it's something definitely we're keen to hear about. If there are aspects of that should be improved in our solution product, we're more than happy to hear about. But as I said, this presentation was not a presentation about ArgoCD itself. There is a lot of capability that are provided by ArgoCD for managing the synchronization, for managing multi-cluster deployments, etc. So the purpose is not to deep dive into ArgoCD, but just to show you and to illustrate how this can be used for the deployment of Layer 7 in simple cases, or when you just have a organization that have not embraced the Layer 7 operator, but are using just bare Helm charts and values file, or if you have more advanced cases and situations with a combination of the Layer 7 operator and ArgoCD. So I hope that does a good illustration of the capabilities that we bring together with ArgoCD. And yeah, feel free to reach out and dig further into the ArgoCD tool, because I think it's a pretty nice tool and good combination with our Layer 7 operator. So thanks a lot, everybody, for your attention and your feedback.
Okay,
thank you.
Thanks a lot, Christian.
Thank you. Thanks everyone for joining today.